Now 9.2, we need to use the information we haven't used yet. They told us here that the volume of the box, the volume, now remember volume is always base area multiplied by the height of the box. We have the base area and we have the height. The base area is going to be W multiplied by L multiplied by H, and they told us that that is 5 units or meters cubed in this case. What else do we know? We know L is 3 W's. Now remember, we got rid of our L's here. So we can say that W multiplied, remember L is 3 W's, multiplied by H is indeed 5. And that will then give us a total volume in terms of W and H. Okay, so we can get our H by itself. This was the big mission here, is to get the height by itself, so that we can then work with the rest of the question and find our expression in terms of W only. So from the volume expression, we now have that H here is equal to 5 over 3W squared. We divide the 3W squared to the left-hand side. And now we can find a volume that is a minimum cost volume box. And that's what they asked us to do in 9.1. Determine the width of the box. So they're asking us to find W down here so that the cost of manufacturing this box will indeed be a minimum. Okay, so we have to find, we've got to go back to our cost function and we have to optimize the cost now that we know the relationship between the height and the width. So let us go and let's write the cost in terms of the width only. So we're going to revisit our cost function. Our cost function then would be 48 multiplied by W multiplied by this H over here, folks, will now be 5 over 3W squared plus 90W squared. So we want to clean this up so that it looks quite nice before we start differentiating. So we've got to take 48, we divide it by 3 and we times it by 6. Now folks, if you do that, you get 80, and then W divided by W squared is W to the power of -1 plus 90W squared. Okay, that's the cost in terms of W. To optimize it, we now have to make our derivative naught. So remember, I'm going to put it under tips here for you. If we optimize, we need a derivative, and in this case it will be C dash W, which is naught. The derivative of the cost with respect to W has to be a 0. Okay, so this is naught, our derivative. So our derivative with respect to W will then be minus 80 W, remember, to the power -2. That power reduces by 1, plus 180 W. And that is what we have to solve, equal to 0. So let's go and do that up here. We get 180 W. Now, what I want to do is I would ideally want to get rid of this negative power. So that is equal to naught. But what I'm going to do is I'm going to take both sides and I'm going to multiply it with W squared so that I get rid of this negative power. My exponential rule comes into play there. Okay, so what do I have? I have 180 W cubed minus 80 for now, which is equal to 0. And that is why I multiplied with a w squared. Now it's easy. What is w cubed? Well, we get w cubed by itself to give us 80 on the right-hand side. We can cancel our 2 zeros. We can divide the 8 by 2. We have a 4 on this side, and we divide the 18 by 2. It gives us a 9. Okay, so for now, what we have here is the w cubed. Let's go back there. W cubed is now 4 over 9. 4 over 9. And what is w? Well, w will be the cube root of the 4 over 9. And if you calculate that, you get 0.76. And that was the question. Determine the width of the box so that the cost is a minimum. So the width need to be 0.76 meters. Now, folks, this is the question that year after year the matrics find very difficult. So if you know your mensuration formula, in other words, you know how to calculate area and volume, make sure you know how to do that so that you can find the volume and the area, surface area of any of the solids that they're going to give you. The most difficult part is finding the function that you need to differentiate. And in this case, it was the cost function. We had it in 2 variables. We need to rewrite it in 1 variable. So for that, they gave us this additional information about the volume, that the volume is 5 meters cubed. So we used that volume, we used the relationship they gave us for the length and the width. We got an expression here that we could use in our cost function to get rid of the h. Once we did that, we prepared it for the derivative, and we continued with the derivative equal to 0, find the derivative, solve it equal to 0, and that gave us the result. Okay, so make sure that you are prepared for one of these. This one was for a total of 10 marks.